So good morning, students. Today we are going to discuss about the answers in the physics topic. So today's the physics questions are very direct questions and very easy. So most of the questions are direct questions. If you know the formulas for the questions, you can directly answer the questions because there is no critical thinking in the question paper. Mostly the level of the question is very easy. So first we are going to discuss about the questions and the answers. So in the first question, they ask the average speed. So initially the object is moving with a velocity v and for half of the distance, and the second half of the distance it is moving with a velocity 2v. So we have the formula. So the formula for this is average velocity is equal to 2v1 v2 by v1 plus v2. So applying the formula in this, we know the v1 value, the first velocity v. Initially the object is moving with a velocity v for half of the distance, and the second half of the distance the object is moving with a velocity v2. It's 2v. So if you apply in this formula, you're getting the average velocity is equal to 2 into v into 2v divided by v plus 2v is equal to 4v square by 3v. Cancelling this, you are getting 4 by 3v. So the answer for this question is 4 by 3v. So, and next question we are going to discuss about the half-life of the radioactive substance. So the half-life is given, the question is T half is given, the question, the T half value is 20 minutes. So we need to find the activity for the 1 by 16th of the initial value. So you all know the formula for the activity. The activity formula is A by A naught. So we need to find the activity for the 1 by 16th of initial value A naught. From that, A by A naught is equal to 1 by 16 is equal to N by N naught is equal to 1 by 2 power N. So the value of N is equal to time taken by T half. So if we equate this, 1 by 16 is nothing but 1 by 2 the whole times of 4 times of 1 by 2 gives 1 by 16. So N value is 4. So applying the N value 4 here, we are getting T by T half. So in the question, they already gave the value of T half. The T half value is 20 minutes. So then the time taken for the activity is 20 into 4 is equal to 80 minutes. So 80 minutes is the answer for this. It's option 1, 80 minutes. So all these questions are direct questions. If you know the formulas directly, you can substitute the given data in the question. You can get the answers directly. Then there is a simplest question. The third question is very simple. So it's a full wave rectifier consists of PN junction diode, a central tap transformer, and a capacitor, and a load resistance. You all know that. So in this question, which component is used to remove the AC ripples from the rectified output? Okay. So the rectified output contains some ripples. So that ripple is eliminated by using a capacitors connecting in series with the full wave rectifier. So the answer for this question is option 4. Then the fourth question, a football player is moving southwards and he is suddenly turning eastwards. with the same speed to avoid an opponent. The force that acts on the player while turning is. So in this question, if he is moving southwards, the frictional force is acting towards the northwards, so north direction. So this is the frictional force acting in the north direction. So this is the initial momentum of the. So always the frictional force acts in the opposite direction. So let us find the force. The force is nothing but the change in momentum. Final momentum minus initial momentum. We need to calculate first the momentum of what is the momentum first. Initially, the player is moving towards the southwards direction. So it's moving towards the southward direction. This is the velocity v1. So this would be initial momentum p1. Then he suddenly turns into the eastward direction. So this is p2. So we know the force is nothing but change in momentum. So p2 minus p1. By using the vector addition, so vector subtraction, this is p2 vector, and this one is p2 vector. So we need to find the p1 vector, which is minus p1 vector, which is opposite to the p1 vector. This is minus p1 vector. Then if you add these two things, this is the resultant vector. This is nothing but change in momentum, p2 minus p1. So this moves along the northeast direction. It just moves along the northeast direction. So the force is also moves along the northeast direction. So the answer for this question is along northeast. Option number 4. So next we are going to solve the question number 5. The question number 5, an electric dipole is placed at an angle 30 degree with the electric field. So theta is given. So theta is equal to 30 degree. So theta is equal to 30 degree. So here we need to find the torque. So torque tau is equal to PE sine theta. So torque tau is equal to PE sine theta. So in this question, the torque is given. Torque is equal to 4 Newton meter. So we need to find the charge. So we know the dipole moment formula 2aq E sine theta, where 2a is the length of the dipole and q is the magnitude of the charge and E is the electric field and theta is the angle between the dipole and the electric field. So all these values are directly given in the question except the charge value. So here we need to find the charge. So torque is 4. The length of the dipole 2a is given, is 2 centimeters. So 2 into 10 power minus 2. So we need to find the charge. And the E value is given 2 into 10 power 5 Newton per coulomb and sine 30. So we all know the value of sine 30 is 1 by 2. So it will get directly cancelled. So solving all this, you are getting the value Q is equal to 2 into 10 power minus 3 coulomb, which is equal to 2 micro coulomb. So which is the charge. So the right option is 2 micro coulomb, option 1. For the first question, the answer is 2 micro coulomb, the option number 1. And the sixth question. So this is also a direct question. So the amount of energy required, or you can call it as a work done, the amount of energy required to form a soap bubble of radius 2 centimeter from a soap bubble solution. So here we need to form a soap bubble of radius 2 centimeter. If you want to increase the soap bubble from a particular radius to another particular radius, we have a direct formula. The formula is nothing but the energy required or work done is equal to surface energy of the final minus surface energy of the initial. So the formula for this is 2T, where T is the surface tension, by 4 pi R2 square minus 4 pi R1 square. Where T is the tension or surface tension which is given in the question. T is given in the question. The radius, the final radius is given, it's 2 centimeter, but the initial radius is not given. So here the soap bubble is formed from the soap solution. So we can consider the initial radius of the soap bubble is 0. So applying the value, so 2, the tension is given. The value of the tension is 0.03. So taking the 4 pi as common, so 4 pi into R2 square minus R1 square. The R2 square is 2 into 10 power minus 2 the whole square value. Here the R1 square is 0, so 0 square. So calculating all this value, you are getting the answer is 3.0144 into 10 power minus 4 joule. So the answer for this question is, so 3.01 into 10 power minus 4 joule. It's option number 4. So next question, it is we need to find the current in the circuit. We need to find the current in the circuit. So we need to find the current in the circuit. So according to Kirchhoff's voltage law, you can consider the loop A. You can consider loop A, B, C, D, A. So we know the formula. So these are the two EMFs here. So if you consider the loop here, this 10 volt is positive and minus 5 volt is negative. It's minus 5 volt. Is equal to, we consider the loop is, we can consider the current direction is this side. So it's I is equal to I into R. So 2I plus 1I plus 7I is equal to 5 volt is equal to 10I. From that I is equal to 5 by 10 ampere is equal to 0.5 ampere. So the answer we are getting is positive. So that the direction assumed by us is also correct. So the current will move from A to B, C, D, and A. So the current will move in this direction. And the value of the current is 0.5 ampere. So the correct answer is option number 3, 0.5 ampere from A to B through E. If the I value, if we get the I value as negative, then the current will move from B to A, not from A to B. And the next question is the eighth question, is a carbon resistor question. So we know the color code of the carbon resistor. The first two colors indicates the digit value, and the third color, that means this 2 and this 2, indicates the digit value. So we know the color code BB Roy, Great Britain, very good wife. It's a mnemonics for that. So black, brown, red. So this first two digit indicates R, red, and second two indicates red color, and the third is a 10 power multiplier. It's 10 power 3. So the third digit indicates the multiplier. So we need to find the color of the third band. So third band is nothing but the 10 power 3. It's 3. So orange is the value for the 10 power 3. So it's orange will come here. So the color code is red, red, and orange. The right answer is orange. The right option is option number 4. The next question is it's a percentage error based question. So we know the formula for the percentage error. First, we need to find the density, possible percentage error in the measurement of density. First, we need to know the formula for the density. So the formula for the density is rho is equal to mass by volume. So the wire is cylindrical in shape. So mass by mass by pi r square h. So del rho by rho into 100% is equal to del m by m into 100% plus, so here r square, so square will come here, 2 into del r by r into 100 plus del h by h. So no need to consider the pi value as a constant. So applying all the values, del m is given the question and m is given the question. The value of del m is 0.002 and m value is 0.4, and the value of del r is given the question is 0.001 and r is 0.3 and h is also given, it's 0.02 and h and del h is 0.02 and h value is 5. So applying all these values, we are getting the answer is 1.6%. So solving all this one, we're getting 1.6% is the percentage error. The answer for the question is 1.6%. So the option 4 is the right one. Option 4 is 1.6%. Then in the next question, there are two bodies, mass m and 9m, are placed at a distance of r. The gravitational potential on the line joining the bodies, where the gravitational field equals 0. So this is the question. So there are two objects. There are two objects, M and 9M. So placed at a distance R. So if we consider the point X from the mass M, the gravitational field becomes 0. So at this point, the field becomes 0. Then the gravitational field at this point is and the gravitational field at this point is Gm by x square, which is equal to the gravitational field due to the 9m. So G 9m by r minus x the whole square. So solving these two equations, G get cancelled, get cancelled. So 1 by x square is equal to 9 by r minus x the whole square. From that, r minus x the whole square by x square is equal to 9 by 1. So taking square root on both sides, we are getting r minus x by x is equal to 3. From that, r minus x is equal to 3x. From that, r is equal to 4x. From that, x is equal to r by 4. So the value of x is equal to r by 4. The value of x is equal to r by 4. So we need to find the potential at x is equal to r by 4, where the gravitational field is 0. So potential V, so minus Gm by x is the potential due to the mass m. So minus G 9m by r minus x. So applying the x value is equal to, we know the x value is equal to r by 4. So applying the x value here, minus Gm divided by, instead of x, apply the value r by 4. Similarly, 9 Gm by r minus r by 4. So solving these two things, we are getting potential V is equal to minus 16 Gm by r. Minus 16 Gm by r. Minus 16 Gm by r. This is the option. The answer for the question is minus 16 Gm by r. So option number 4. And the 11th question is a direct question. So the error in the measurement which arises due to unpredictable fluctuation in temperature and voltage supply. This is due to unpredictable temperature and voltage supply. So this is due to the random error. So not because of instrumental or personal or least count error. This is only because of random error. The answer is random error. So this is the direct easiest question. Then the 12th question. So it's a statement-based question. So the statement 1, photovoltaic devices can convert the optical radiation into electricity. Yes, converts the optical energy into light energy into electrical energy. It's a right statement. Then a xenon diode is to operate under reverse bias in breakdown region. In the light of the above statement, choose the most appropriate answer from the given option. So both the statements are true here. So yes, the photovoltaic device can convert light energy into electrical energy. And similarly, the xenon diode operates in a reverse bias condition. So both the statements are true. So both statements are correct. So that's the right answer. So next we need to find the frequencies of the fundamental frequency harmonics produced by the open pipe and closed pipe to that of closed pipe having the same length. So this is the direct formula substitution. So we have the formula. The frequency of open pipe to the frequency of closed pipe is equal to V by 2L into divided by V by 4L. So is equal to V by 2L into 4L by V. So this get cancelled. So 4 by 2, which is equal to 2 by 1. So the ratio is 2:1 is the ratio. So the option for this answer is 2:1. Option 3. It's option number 3. So next we are going to the work function of the cesium is given. Cesium, potassium, and sodium is given. It's 2.14 electron volt and 2.30 electron volt and 2.7 electron volt respectively. So if the incident electromagnetic radiation have an incident energy, it have the energy of 2.20. The work function is nothing but the minimum energy required to remove the electron from the metal surface. So to remove the electron from the cesium, we need 2.14 electron volt. But in case of potassium and sodium, it requires 2.30 and 2.75 electron volt. But the incident radiation has only 2.20. So only this radiation can be able to remove the electron from cesium because cesium has the work function 2.14. Others two, but the other two, potassium and sodium, have the value greater than the work function value greater than the energy of the incident radiation. So the photoelectrons emit only in cesium metal, not in potassium and sodium, because the work function of potassium and sodium is greater than the incident energy of the electromagnetic radiation. So the correct answer is cesium only. So this is a very easiest question. If you know the concepts clearly, you can able to answer these kind of questions easily. So this time the most of the questions are direct questions. 90% of the questions are direct questions. Then another one direct questions. the net magnetic flux through any closed surface. If there is a closed surface, if you place a magnet inside the closed surface, the magnet always exists as dipole, for example, north pole and south pole. So the magnetic field due to the north pole is towards outwards, and the magnetic field towards the south, due to the south pole is inwards. So these two magnetic field lines cancel out each other. Hence, the total magnetic flux is always zero because the magnet does not exist as monopole. Always the magnet exists as dipole. So the answer for this question is 0. So 0 is the right answer. So the next question, a wire is suspended from the ceiling. So there's a wire, it is suspended on the ceiling support, stretched by a weight of W attached to its ends. The longitudinal stress at any point of area of cross section A we need to find. So we know the formula, longitudinal stress is equal to force by area, so F by A. Here weight is the force acting on it, so just W by A. The answer for the question is W by A, option number 3. Then the next question we need to find. So the next question is, the minimum wavelength of X-ray produced by an electron accelerated through a potential difference of V volt is proportional to. So for the wavelength of the electron, we know the formula lambda is equal to 12.27 divided by root V angstrom. So angstrom is 10 power minus 10 meter. So in this question, these are the constants. So lambda is inversely proportional to root V. So this is a direct formula question. So the answer is 1 by root V is the answer. So 1 by root V is the answer. The right answer for this question is 1 by root V. The next question. The Carnot engine has an efficiency is given, it's 50%, when its source is at temperature of 327 degrees Celsius. And we need to find the temperature of the sink. So we know the formula for the Carnot engine. Efficiency formula, we already know that efficiency is equal to T1 minus T2 by T1. So T1 is the temperature of the source and T2 is the temperature of the sink. So we need to convert the Celsius into Kelvin. So if you add 273 to this, we are getting 600 Kelvin. So T1 is 600 Kelvin. So 600 minus T2 divided by T1. The efficiency is 50%. So 50 by 100 is the. So here T1 is also given in the question. It's 600. So solving this, we are getting the value of T1 and T2 as . it's 300, 600 minus T2. From that, T2 is equal to 600 minus 300, which is equal to to 300 Kelvin. We convert the 300 Kelvin into Celsius. So subtract by 273, we'll get the value in Celsius, which is equal to 27 degrees Celsius. The right option is 27 degrees Celsius. So the next question is, in a hydrogen spectrum, the shortest wavelength of the Balmer is lambda. So the lambda value of for the Balmer series is 4 by r. So we know the already formula 1 by lambda is equal to r divided by 1 by n1 square minus 1 by n2 square. Okay. So here n1 is for the Balmer series. The value of n1 is equal to 2. So apply in this, we are getting lambda value is 4 by r for the Balmer series. And for the shortest wavelength, then you will get the shortest wavelength, and the electron jumps from the infinite orbit to the second orbit. Then you will get the shortest wavelength in a Balmer series. So the lambda value is equal to 4 by r. Similarly, the shortest wavelength for a bracket series is 16 by r. This is for bracket series, and this is for Balmer series wavelength. So Balmer series. So for Balmer series, the value is given as lambda. So for the bracket series, the lambda is 16 by r. So we can write the 16 by r is equal to 4 into 4 by r. So instead of 4 by r, we can write lambda here. So it is equal to 4 lambda. So the shortest wavelength for the Balmer series is 4 times of the shortest wavelength of the Balmer series. The shortest wavelength of the bracket series is equal to 4 times of the shortest wavelength of the Balmer series. So this is the right option. So the next question. So a bullet is fired from a gun at a speed of 280 meter per second. Its initial velocity is given in the direction of 30 degree above the horizontal. So it's 30 degree above the horizontal. The maximum height attained by the bullet. Okay, it goes in a projectile like this. Okay. So the path of the projectile is it's parabolic. So we know the formula for the projectile. So H max, the maximum height for the projectile is equal to u square sine square theta divided by 2g. So you should take the g value is 9.8 meter per second, as well as the sine 30 value is given is 0.5. So the initial velocity is given, u is given, it's 280 meter per second. So if you apply all these values in this question, you are getting the answer. So apply all these values. It's u square is 280 square into 0.5 square whole divided by 2 into 9.8. We solve all this value, or getting the value is 1000 meter. So the answer for the question is 1000 meter. Okay, the option 4 is the right answer. Then in the Young's double slit experiment, two statements are given below. First one, if screen is moved away from the plane of slits, angular separation of the fringes remains constant. Yes. So if the screen is moved away from the plane of slits, the angular separation of the fringes, yes, it will remain constant. Then next one, if the monochromatic source is replaced by another monochromatic source of larger wavelength, then the angular separation of fringes decreases. Actually, it not decreases, it will increases. So the statement 1 is the correct one, and the statement 2 is the wrong one. So the option for this one is option number 4. The statement 1 is true, and the statement 2 is false. So option 4 is the right answer here. Then we need to find the magnetic energy stored in the inductor. We know the formula for the inductor. The magnetic energy stored in the inductor L is equal to energy E is equal to half Li square. This is the magnetic energy stored in the inductor. So I value is given as 2 ampere, and the inductance value is 4 microhenry. So 1 by 2 into 4 into 10 power minus 6 into 2 to get cancelled. Sorry, it's 2 square. So 2 into 2, this 2 and this 2 get cancelled. So 4 into 2, 8. So 8 micro joule is right answer. The option 1 is the correct answer for this. Next one. Here the flux is 0 over a surface. Okay, over a surface, if the flux is, this is nothing but a flux. If the flux is 0, then which one is the correct one? So if the flux is 0, the number of flux lines entering the surface must be equal to the number of flux lines leaving the surface. Then only the flux get 0. So the right option is option number 2 for this. Then the next question. The potential energy of a long spring is given when stretched by 2 centimeters. So the x value is given is u, and if the spring is stretched by 8 centimeters, the potential energy is, we need to find the potential energy. We know the formula. So u is equal to, for example, for 2 centimeter, let us take this is u equal to half k x square. So this is the potential energy for the first spring, and the potential energy of the second spring is u2. Let us take this u2, so it's half k x1 square, it's x2 square. So applying the values, so this half k get cancelled, half k get cancelled. So u1 by u2 is equal to u1 by u2 is equal to x1 square by x2 square. So x1 value is given. The value of x1 is given 2 square by 8 square. So it's 4 by 64. Which is equal to u by u2. From that 1 by 16. So from that u2 is equal to 16u. The right answer is 16. So option 1 is the right answer. So the option 1 is the right answer. So next question, we need to find in the LCR circuit, we need to find the frequency for the at resonance condition. So frequency for the resonance condition, you know the formula. This is also direct formula question. F is equal to 1 by 2 pi root LC. So 1 by 2 pi root LC. So applying the value. So L is given. L is equal to 10 millihenry and C is equal to 1 microfarad. So apply the value in this question. We're getting the answer 1.59 kilohertz. It's 1.59 kilohertz. So option 1 is the right answer for this. Formula. So I is equal to, you know, formula I is equal to V by XC, capacitive reactance. So XC is nothing but 1 by omega C. So applying this one, the value we are getting I is equal to V into omega C. If the operating frequency decreases, then I value also decreases, then the displacement current also decreases. So the right answer is option number 4. Then the next question, So Venturi meter. So Venturi, we all know that it's a direct question. The Venturi meter works on the Bernoulli's principle. So the Venturi meter works on the Bernoulli's principle. The option is 3. So option 3 is the right answer. Then the 29th question. Okay, then the next question is the 29th question. So a 12 volt 60 watt lamp is connected to the secondary of the step down transformer. It's connected to the secondary. So this is an output. So 12 volt. So 12 volt and 60 watt is the output power and the output voltage, whose primary is connected to the AC mains of. So input voltage is 220 volt. Assuming the transformer is an ideal transformer. So for an ideal transformer, we all know that the input power is equal to output power. So we know the formula input power is equal to output power. So input power is equal to output power. From that, the input power is what? 60 watt is equal to output power. So what is the output power here? So output power is equal to output voltage into output current. Here we need to find the so here the input voltage, output voltage is given. The output voltage is sorry students. So this is the question. So here we need to find the what is the current in the primary winding. That means the input current we need to find. So output power is given and output voltage is given. So first, by using the output power and output voltage, find the output current. So output current is equal to P out V naught I naught. So from that is equal to P naught. So it's 60 12 into I naught. From that I naught is equal to 60 by 12 is equal to 5 ampere is the output current. So in the formula I naught into V naught is equal to input current into input voltage. So we need to find the input current. II is equal to, so it's 60 watt divided by V output, so V input. So V input is 220, so 60 by 220. We cancel this at the value 3 by 11 is equal to 0.27 ampere. The value is 0.27 ampere. So the value is input current is equal to 60 by 220. We cancel this for getting 0.27 ampere. So the answer for this is 0.27 ampere. Option number 2 is the right answer. So next, so in the, if the galvanometer G does not show any deflection in the circuit, the value of R we need to find. So we need to find the value of R. So the value of R, if the galvanometer does not show any deflection means, so there is no current flows in the circuit. The current flows in the galvanometer is equal to 0. That means this circuit is not, we don't need to consider this circuit. So we need to consider only this circuit, which is equal to V by R. Here, these two resistors are in series. So there is no current flows in the galvanometer. So these two resistors are in series, and that is equal to V by 400 plus R. The value of V is equal to 10 volts. So 10 divided by 400 plus R is the current flows in the circuit. So we find the value of I is equal to, so find the value of I here. The value of I is equal to 10 divided by 400 plus R. Then we know the formula V is equal to IR is equal to 2 volt in the right side. So applying the value, I is equal to 10 divided by 400 plus R into R is equal to 2 volt. From that solving these one, we are getting the answer R value is equal to 100 ohm. So the right answer is 100 ohm. So the right answer is 100 ohm. So option 4 is the right answer. So option 4 is the right answer. The next one, in a plane electromagnetic wave traveling in free space, the electric field components oscillate sinusoidally at the frequency of 2 into 10 power 10 hertz, and the amplitude is given. Then we need to find the amplitude of the magnetic field. So the amplitude of the magnetic field is option number D. It's 1.6 into 10 power minus 7 Tesla. Then the next question is 33rd question. So we need to solve the equivalent capacitance value. So these two capacitance are in parallel. So Cp is equal to C1 plus C2, which is equal to 3 plus 3, which is equal to 6 microfarad. Then this 6 microfarad, then this 3 microfarad is in series with the 6 microfarad. So then use the formula 1 by Cs is equal to 1 by C1 plus 1 by C2 is equal to 1 by 3 plus 1 by 6. If you solve this, you get the answer 6 plus 3 by 8. 6 plus 3 by 80 equal to 9 by 80 is equal to 1 by C. From that, C is equal to 18 by 9. C is equal to 18 by 9. We cancel this, we are getting 2 microfarad. So 2 microfarad is the right answer. The answer is 2 microfarad. Then, so for the angle of gyration for the solid sphere of mass m and radius r, about its own axis. So the radius of gyration for the thin hollow sphere of same mass and radius. So which is in the ratio of 3:5. The answer is option number 2. It's 3:5. So this is the right option is option number 2. Then the radius of the innermost orbit of the hydrogen atom is, that means R naught value is, Bohr's radius value is given. So what is the radius of the third allowed orbit of hydrogen atom? So we know the radius formula is equal to n square by z into R naught, where R naught is the Bohr's radius. So here n is the third orbit. So it's 3 square. Here z value is 1 because the atomic number of hydrogen atom is 1. So R naught value is given, it's 5.3 into 10 power minus 11. So multiplying this value, 9 into 5.3 into 10 power minus 11. So you will get the answer for this. So it's 4.77. It's 4.77 angstrom. The option for this is 4.77 angstrom. So then next one, the electric potential at point P due to a dipole, it's 10 power 2 volt. So for the V axial, so the electric dipole, this is the diagram here. This is the axial point. So for the axial point, the V axial, we have a formula. V axial is equal to electric field due to plus Q charge plus electric field due to minus Q charge, which is equal to the electric field due to plus Q charge is KQ by 2, and the electric field due to minus Q charge is minus KQ by 8. So taking the KQ as common, we are getting 1 by 2 minus 1 by 8. So taking the LCM, we are getting 8 minus 2, so KQ divided by 8 minus 2 divided by 16 is equal to KQ divided by 6 by 16. Cancel this, you will get KQ by 3 by 8. So the answer is KQ 3 by 8. So the right answer is 3 by 8 KQ. The option number 2 is right answer. Option number 2 is right answer. Next question. The 38 question in this graph, we need to find the acceleration of the particle at t is equal to 2 seconds. We need to find the acceleration of the particle. We know the formula for the acceleration. Acceleration is equal to A is equal to it's minus omega square amplitude. So omega square into amplitude. So in the formula, omega square is equal to 2 pi f. So minus 2 pi f whole square into amplitude. So instead of frequency, they gave the time period. So 2 seconds. Okay, 2 is the time period. So we can write acceleration is equal to minus, instead of 2 pi by t the whole square into amplitude. The acceleration value is equal to minus 2 pi by time period by whole square into the amplitude value is 1. So this is here the amplitude value, here the amplitude value is 1. So the time period is 2 here. So applying all these values in the formula, so we are getting 4 pi square by 4 into 1. So 4 and 4 get cancelled. So the right answer is minus pi square by 16. So A max is equal to minus omega square A. So instead of omega, we can write minus 2 pi by t the whole square into A. So from that, we can write minus 4 pi square by the time period is, this is the time period of this amplitude. So time period is equal to 8. So 8 square will become 64 into A, where the amplitude value is 1. So by 1. So this get cancelled. So minus pi square by 16 is the right answer. Minus pi square by 16 is the right answer. So the answer for this question is minus pi square by 16 meters second power minus 2. Option 1 is the right answer here. Then here 10 resistors, each of resistance R are contained in series. So a battery of EMF E and negligible internal resistance. Then those are contained in parallel of the same battery. The current is increased by n times. You need to find the value of n here. So we know the formula, the R equivalent, if n resist, the R equivalent for the 10 resistor contained series is 10R. From that, current in this resistor is equal to V by R, which is equal to V by 10R. From that, V by R is equal to 10I1. This is the current in the series circuit. If the resistors are contained in parallel, then the equivalent resistance R equivalent is equal to R by 10. Then the current in the circuit is I2 is equal to 10 V by R. From that, I2 is equal to, instead of V by R, we can write 10 I1. So apply here. We are getting 10 into 10 I1. So we are getting 100 I1. So the value of I2 is equal to 100 I1. So the correct answer for this question is 100. Option number 3 is the right answer. Option 3 is the the current is increased by n times. So the 100 I1, so 100 times is the right answer. Option number 3 is the right answer. Then the question number 40, the horizontal bridge is built across a river. A student standing on the bridge throws a small ball vertically upwards with a velocity 4 meters per second. The ball strikes the water surface after 4 seconds. The height of the bridge above the water surface is. So a small boy is throwing a small ball vertically upwards the velocity. This is the initial velocity of the ball. So U is given the question. So initial velocity of the ball. And after 4 seconds, the ball strikes the water surface. So we need to find the height of the bridge above the water surface. So G value is given. So for this, you can use the kinematics formula. S is equal to ut plus half gt square. So the u is -4. The time taken is 4 plus half. The g value is 10 and the time taken is 4 square. So solving this, you are getting 80 minus 16 is equal to 64 meter. The answer is 64 meter is the right answer. So option 4 is the right answer. Option 4 is the right answer. Then 41st question, we need the platinum, a resistance of platinum wire is given at temperature is equal to 0 degrees Celsius. The platinum wire has a resistance of 2 ohm and 6.8 ohm at 80 degrees Celsius. We need to find the temperature coefficient of resistance. So for this, we have a formula for the temperature coefficient of resistance. Alpha is equal to del R by R into del T. So del R is equal to change in resistance, which is equal to 6.8 minus 2. Is 2 is the initial resistance. What is the change in temperature? It's 80 minus 0. So solving this one, we are getting the value 4.8 divided by 160. So solving this, the alpha value becomes 3 into 10 power minus 2 degrees Celsius power minus 1. So this is the answer. The alpha value is 3 into 10 power minus 2. Check the answer. Yes, 3 into 10 power minus 2. The option 4 is the right answer. So option number 4 is the right answer. So option 4 is the right answer. The next one. A wire carrying a current I. Sorry, no. So wire carrying a current I along the positive x-axis has length L. It is kept in a magnetic field B. The magnitude of magnetic force acting on the wire. So the current is going along the positive x direction. So the magnetic field has a vector. Okay. The value of the magnetic field vector is given. So we need to find the magnetic force. So we know the formula for the force. The force value is equal to so the value of force phi acts along the x-axis. So B vector is given. The value of B vector, this question. The value of B vector is 2 I cap. So F vector is equal to I into L vector cross B vector. So the value of I is it's not given the question. So let us take the L vector is equal to L I cap because it is the positive x direction. So B vector value is given. So B vector value is the value of B vector is 2 I cap plus 3 j cap minus 4 k cap. So 2 I cap plus 3 j cap minus 4 k cap. So if find the L vector cross B vector. So using the determinant method, I cap, j cap, and k cap. For the L value, the I is L. Or you can take it as 1, 0, 0, and 2 plus 3 minus 4. If you take the determinant for this, you will get the value of force is equal to F is equal to root 5 I into L. So the I value and L value is not given in the question. So you can directly substitute I and L as it is. So the correct answer for this 42nd question is, sorry. So the right answer is root 5 into IL. It's the right answer for this. Option 3 is the right answer, root 5 into IL. If you take the determinant for this, you will get the answer. Then the net impedance of the circuit, we need to calculate the net impedance of the circuit. So to find the net impedance of the circuit, we need to calculate the XL value as well as XC value. So the impedance value is Z is equal to root of R square plus XL minus XC the whole square. So the value of XL is equal to omega L. So omega is equal to 100 2 pi f, it's 100 pi. So into L value is 50 by pi into 10 power minus 3. So cancelling this, you are getting the XL value is 5 ohm and XC is equal to 1 by omega C, which is equal to 10 power 6 divided by 100 pi into 1000 by pi. So solving this, you are getting 10 ohm. So substituting these values in the Z values, that is equal to root of the R value is 10. So R square is 100 my plus. So XL minus XC. So here XC is greater. So XC minus XL will come. So XC is 10 and XL is 5. So 10 minus 5 gives 5. So 5 square is 25. So we get Z value is equal to root of 125, which is equal to 5 root 3. So the Z value is equal to, the value of Z is equal to 5 root 3 ohm. So the right answer for this option is 5 root 3 ohm. It's on 5 root 5, not 5 root 3, it's 5 root 5. The option is 5 root 5. Option D is the, option 4 is the right answer. Calculate the maximum acceleration of the moving car so that the body lying on the floor of the car remains stationary. We need to find the maximum acceleration. So the without the body lying on the car will not move. So what is the maximum acceleration? Can the car will move without the object, the car moves. So the coefficient of the static friction of the bar between the body and the floor is given. So for this, we have a formula. We have a direct formula. The acceleration is A is equal to mu g. So it's 0.15. Take the value of g is 10. So it is equal to 1.5 meter per second square. So the value of acceleration, maximum acceleration of a moving car is 1.5 meter per second square. So option 4 is the right answer. Then 47th question, or no, 47th question. So here input A, we can write the logic gates A, B. So 0, 0, 0, 1, 1, 0, 1, 1. We need to find the output. So this is A bar and this is B bar. So this is an AND gate. So A bar dot B bar. So what is A bar dot B bar? So A bar is 1, B bar is also 1. Then the answer will be so A bar dot B bar. So it's not NAND gate. It's not AND gate. It's NAND gate. So A bar dot B bar, the whole bar is the answer. Is the signal given here. So according to Boolean algebra, we have the the value. You can write here. So according to Boolean algebra, we can write A bar dot B bar, the whole bar is equal to A plus B double bar is equal to A plus B. So it will gives the OR gate. So for the OR gate, the value is 0, 1, 1, 1. So this is the right option. So the option is 0. The answer is 0, 1, 1, 1. So if we are trying to Boolean algebra, we are getting A plus B as output. The right answer is option number 3, right answer. So option 3 is the right answer. So option 3 is right answer. Then 48th question. So here the lens is placed in a water here. So the both radius of curvature of the lens is equal 20 centimeter. So it is placed in a refractive index of the lens is 1.5 and the refractive index of the lens is 1.5 and the liquid is 1.6. So we know the formula to find the focal length. So lens maker's formula, we know lens maker's formula. The lens maker's formula is 1 by f is equal to n2 minus n1 by n1 by 1 by r1 minus 1 by r2 So using this formula, the focal length is minus 100 centimeter. So the option for this answer is minus 100 centimeter. So next, the last question. So we need to find the two thin lengths are same focal length. One is convex and one is concave. When you place in context, we need to find the equivalent focal length. So to find the equivalent focal length, we have the formula 1 by f is equal to 1 by f1 plus 1 by f2. So one is convex, so it's 1 by f. Concave is minus 1 by f. So you are getting 1 by f value is 0, then f value is equal to 0 by 1. Anything by 1 is infinity, so the answer is infinite. So thank you, students. So thank you so much.